situation. Ready to start? All right. As we're doing our pressure test, we're also going to set up the rest of our tools. Next thing to happen after the pressure test is our system evacuation. So for system evacuation, we're going to use the large hose. This is a 3/8 hose at least. Hook this directly up to my vacuum pump. So on your vacuum pump, you may have different ports or different outlets, 1/4 inch, 3/8, and 1/2 inch. No matter which one you are using, it'll still work as a vacuum pump, but the fastest way for this to work is to use your largest hose diameter. If you're ever worried about keeping the inside of your caps clean or not losing them on the job site, whenever you take the cap off, you can throw it onto that placeholder at the back of your gauges. It has been about half an hour. So we have passed our pressure test. Check here, the pressure is still the exact same. If it's been 24 hours and there's been a temperature change, we might do some calculations, go through our gas laws to make sure we didn't lose a pressure, even though we changed temperature and lost some pressure. So at this point, we have held pressure, our system's ready to go. I'm ready to evacuate and move on to our next step. In this case, my setup is the exact same. Lift to my liquid side, suck to my suction side, service hose to my nitrogen, vacuum hose to my vacuum pump. First thing to do, get rid of all that nitrogen pressure. There's 180 PSI in there. If I put that to my vacuum pump, the oil's gonna shoot out the back of that and spray the wall or the roof. Don't do that. It hurts your pump, and you're gonna have a couple hours of cleanup to do. So, to start this, I'm gonna start relieving all my pressure out. Slowly open my service hose, open both sides of my gauges, and let all that nitrogen right out right here. I'm waiting to get down close to 0 PSI. I don't have to get all the way down to 0. I want to be really close. Any pressure above 0 PSI can start pushing some oil out of your vacuum pump. You don't want that. All right, we're down now just above 0, probably about 5 PSI. I'm going to close up everything. And I'm going to come back here, I'm going to close off, fully backseat, again, both of my 3-position service valves.
Now I know those are 3-seaters, so they probably don't have have Schrader cores, but if they did, you'd want them gone to speed up the process?
If they had Schrader cores, I would try to remove those as early in the process as possible to speed up things like filling with pressure or recovering gas. In the case of a 3-position service valve, we don't need to remove any Schrader cores because the valves do a better job of opening and closing. However, they can sometimes leak, so watch those. Now, start up with the vacuum pump. Check if your oil is in there. So I definitely have oil in here. If you run a pump without oil, if you run any motor without oil, it will damage it. Gonna plug this in. My blank off valve is shut, my ballast is shut, all my valves are shut. This process, very important. I start my vacuum pump. That's gonna pull down, down, down into a good vacuum. What I'm waiting for is the sound of that vacuum pump when it is finished pulling the vacuum. You may notice that the oil level rises a bit as we keep this running. As oil warms up, it expands, fills up more space. When this pump is warm, you want the oil level right there. Not when it's cold, rolling around the back of your van. So now that this is running, I can hear a small difference when I open things up to oxygen. So I want you to listen really carefully to the sound this makes when I open my blank off valve on this side. it has a lower tone gurgle. That was the air coming out of this hose. That sound went away, so I know my hose is connected fully. If there's an issue with that, like if this hose wasn't connected all the way, you would continue to hear sounds like that. This is a quick way to make sure that you're actually going to pull a good vacuum, not be waiting for it to do something when you have a loose hose. So I'm now going to go through the process for each of these hoses all the way through. So I'm going to do the same thing here, where I open my high side and my vacuum. There it goes. It goes back to that same sound. So this hose is totally evacuated. I can check my micron gauge to make sure that it's pulling a good vacuum. This one's already well below 500 micron. So we know that this is pulling really good. Same thing, I'm going to open my low side. Hear that same sound again. That's just the air in this blue hose. Now we're back to that point. Good sound, great vacuum. Last step here. I have one thing that can cause me issues, it's the ball valve. When a ball valve turns, it can trap a small amount of air outside of it. So while it's pulled down like this, I like to crack open any ball valves that are in the way, like on this core removal tool. Throw that over to a 45, and you may have noticed this number jumped. It jumped up because it released air inside this ball valve. Now I can put that back to straight, pull in great vacuum. Now we're going to evacuate our system.
Can you encounter the same problem with seated valves?
No.
Okay.
Seated valves won't give you that same issue.
I assume you do that for every ball valve on the system?
If you have other ball valves, you'd want to do that too, yes. So if you have multiple ball valves throughout a system that you're evacuating with, you would also, if possible, crack those off to get any of that air out as well. Now I'm going to mid-seat both of these, and you heard that difference in the vacuum pump again. That is pulling everything that's left in this system out. As our vacuum pump can take a certain amount of time, and it will eventually ruin the oil as it pulls down on the system, we want to do something here called opening the ballast. This ballast is going to let that system pull all the nitrogen and contaminants out of that system, but it's going to bypass the second stage that the pump goes through. That means that the wet, moist, dirty air that's coming out of the system is in contact with the vacuum pump oil for half that amount of time. On a larger system, this will stop you from changing the oil multiple times and can be a little bit faster. So it saves you from changing the oil and speeds up your evacuation. When you get down between 3,000 to 5,000 microns on your system, at that point, you'll want to close that ballast back off. Now that we've closed that ballast, the vacuum pump is going through both stages of that evacuation. First stage, pulling into the vacuum pump. Second stage, pulling out of that first stage, and then coming through our exhaust. We're waiting for it to get down to roughly 1,500 micron, which it's at right now. I'm going to pause. We're going to do something called triple evacuation.
How often would you change the oil on one of those?
The oil gets changed when it's required. So as that oil gets dirty, by the manufacturer's suggestions. Read the manual, and we tell you in there how often to change the oil or how to check the oil. So for a triple evacuation, I want to pull down to roughly 1,500 micron. And I went even past that, it's down to 1,000. What I'm going to do is now introduce a small amount of nitrogen. Very small. I'm going to back this back off, open this tank up. I'm going to open our service side to our system. I'm going to introduce a very small amount of nitrogen. I don't even have to get back up to 0 psi. So right there, I put some nitrogen in there. I'm still just under 0 psi. This has risen up. This nitrogen is in effect rinsing out anything that might be left in the system. We've done our first clean. This is going to be our second. We do one more, and that's our triple evacuation.
And the reason why you don't have to go to positive PSI is because the nitrogen as a vapor will expand to fill the space.
Yes. So after we introduce that nitrogen, it will take up all the space that's left in there. We don't want to go back up to another pressure test, so we have to relieve that again so we don't hurt our vacuum pump. Just a little bit to rinse it out.
What was it you mentioned about having to trade off with the valves so that none of that nitrogen is in constant contact with the vacuum pump?
I'm not sure.
Oh.
What's the question?
Well, like
Again.
when you're putting the nitrogen into the system, you're not supposed to have the valve that leads to the vacuum pump on.
Yeah, we shut off our vacuum pump out of gauges.
Yeah.
You can also use your blank off, but I'll use that at the end.
And that's for the same reason as too much PSI, boom.
Yeah.
Okay.
So, first step for our triple evac. So we're done with that. I'll close my service hose, open back up my vacuum. We have that same gurgling sound again, but this is going to drop really fast. This helps speed up evacuation processes. Even though you're doing extra steps, it can help speed up a system, especially if it's been open to a moist environment for a long time. This is dropping past 6,000 already. So this will only take another couple minutes before that's done.
So the lower the microns, the deeper into the vacuum is?
Yes. The lower the microns, the deeper vacuum we have. Minimum that we're going to end up going to is 500. Depending on the manufacturer, they may ask to do things like a triple evacuation, and they may ask to go to an even deeper vacuum. The definition of a deep vacuum within the B52 refrigeration codebook is 500 microns. So that's the bare minimum by code we can go to, but some manufacturers will suggest you go even deeper.
Are there negative microns?
There's not negative microns, no. This is already at 3,250, dropping. Wait for that to get down to about 1,000, and we'll do another flush of nitrogen.
The reason why it starts to slow down, is that because any moisture that's left is in liquid state, so it has to boil off?
As we get less and less actual volume inside of gas in that system, it gets harder and harder to pull it out. So it's harder to pull a deep vacuum than it is to pull a small amount of vacuum from a high pressure.
Okay.
So the further apart two things are, the easier it is to transfer that energy. Same with heat, same with vacuum. The closer they get to each other, the harder it is to finish that cross that finishing line. So we're back down, we're past 1,000 now. So I'm going to do that same process. Shut my vacuum. Go back here, open my nitrogen, put a bit of nitrogen in there. The pressure rises back up. Shut that off, and we can fully evacuate again. So vacuum all the way open, both sides all the way open. I'm done with this nitrogen. Hose is off. I can turn my nitrogen off and start taking this down. I still have a couple more minutes before I finish my evacuation. So in this time, I'm going to clean this up, get it out of my way. If there's any pressure left in there, release that. Go back to all the way back to off. And then reg. Take it off. Every time you finish using any cylinder, regulators should come off. So my regulator is now out of the way. Safekeeping. And my last step, as I'm evacuating, I'm going to get ready for recharging my system. In this case, I'm going to set up for active charging. So in active charging, I can reuse my recovery unit to push refrigerant back into the system. So I have a hose going from my liquid side to the intake of the recovery unit, and from the outlet port of the recovery unit into my system. If you're moving a lot of refrigerant, this is the best way to do it, it's the fastest. If you only need a little refrigerant, you can do a passive recovery, which is passive charging in this case. Hook this hose up directly to your recovery cylinder. I have lots in here, so I'm going to do that. I'm going to put this hose right to my liquid. Now that I've done that, we got one more problem, and that problem is that this hose is full of air, so I need to purge that somehow. One of the easiest ways I know how to purge that hose is just going to be evacuated, just like you do in the rest of your hoses. So at this point, I can open up my service valve, and that'll evacuate all the air that's in the hose. Otherwise, I can open that liquid side and purge the refrigerant out this side. Either one is acceptable, either one will work. Dropping. All right, we're now waiting for our final evacuation. This has to get to a minimum of 500 micron. Once we hit that 500 micron, we will then be closing off our gauges, slowly shutting all the ball valves off, taking our vacuum pump away, and doing a decay test. The decay test is a minimum of 10 minutes, where we have to hold under 1,000 microns. So bare minimum, we pull down to 500 micron, and for 10 minutes of time, that micron gauge cannot rise above 1,000. If it rises above 1,000, and then plateaus somewhere between 1,000 and 4,000 micron, it's likely that there's some moisture left in the system that has now just slowly boiled off or gotten out of the oil. If that micron gauge slowly keeps creeping up and doesn't plateau, it just keeps on slowly going up and up and up, you have a leak somewhere. And a leak under a vacuum is a very difficult leak to find. All right. So once this cools down, we'll then be doing our decay test of 10 minutes. This could take a couple minutes, so again, if you can find something else to do, clean up. Nitrogen tank is done, let's put it away. Paperwork, let's start doing some paperwork. A couple things that should be noted on every system. What the pressure test was done to. So I'll write that down. Pressure test to 180 psi. The duration of that pressure test. That was a half-hour pressure test. The date of that pressure test. March 17th. And if you can, throw your initials on there in case somebody has questions for you. Same thing for your vacuum. You're going to want to write that down on your startup report. What did you pull that vacuum down to? If you only pulled it down to 600, probably not far enough. We're going to make a note. I pulled the vacuum down to 345 micron, let's say. And I did make a decay test for 10 minutes, after which the micron gauge rose to 600. Having these details every time you do a system means that there's no question you did the right job. All right. We're going to edit this out. I'm just going to skip this part. But we're going to say we got down to 500 here.